Hello friends, welcome to the next lecture in the series of Cosmological Perturbation theory. In the last video we looked at this transformation of rank 1-1 tensor perturbation in a tensor of rank 1-1, and this is perturbation in gauge 1, this is perturbation in gauge 2, and they are related according to this equation where the bar indicates that the value of f alpha beta in the FRW coordinate system. Now in this video we are going to look at different components of this transformation, meaning we are going to look at 0,0 component, we are going to look at I0 component, 0I component, and IJ component. In this case, one index is on top and one index is at the bottom. So I0 and 0I, we need to treat them separately. We need to look at them separately, and let us see what the result comes out to be. In the previous example, we had alpha beta both on the lower side. They both were lower indices. So I0 and 0I, they were the same. But in this case, we'll calculate them separately. Before we do this, we can simplify this expression by applying homogeneity. If we apply homogeneity to the background universe, we apply homogeneity to the background universe, apply homogeneity to the background universe, then you can see, and we'll do the same what we did in the last video, in the last example. Not in the last video, but in the last example of f alpha beta both on the lower side, we saw that this quantity in homogeneous universe will not vary with respect to the spatial indices. So its partial derivative with respect to spatial indices will be 0. So if we contract this, expression, this term on gamma, then only the 0 index will survive. The partial derivative of f bar, the background value, alpha beta, f bar alpha beta, the value in the background universe, its partial derivative with respect to the spatial indices, with respect to x, with respect to y, with respect to z, will be 0. So only upon contraction, only the 0 index will survive. All right, so let's start with this expression. Let's first do the 0,0 component. 0,0 component. Zero component is, this is 0, this is 0, 0, 0, 0, 0, and then here we have alpha 0, beta 0, alpha 0 and beta 0, mu and nu, these are two arbitrary indices. So mu I can replace with nu in this expression, and then these two terms will cancel each other. So I hope this makes sense. Cancellation of these two terms, because if you contract this on mu, you will get 0 0 1 1 2 2 3 3 term, and here if you contract on mu 0 0 1 1 2 2 3 3 term. So mu you can replace with any other symbol here. For example, I can replace it with new symbol, and then if I replace this with new letter, I say new here and new here, then this new and this new. So this term and this term become the same, and they cancel each other. For those of you who are expert in all this, because you have seen it in general relativity and also in the standard cosmology, you may find it a bit boring, my explanations about this trivial things about how these two terms cancel each other. But just so that all of my viewers can be on the same page, sometimes some small concepts become rusty over a period of time if we have not practiced them. So for those audience, I am explaining about these small things. I hope the other who have done a lot of practice on this type of stuff, they will not find it insulting or boring. So please bear with me if I explain the small things which are otherwise very obvious. Okay, so I think this is as far as we can go with the simplification. So 0 0 component is this. So 0 0 component from gauge 1 transforms to the gauge 2, 0 0 component in gauge 2 according to this expression. Now let's look at 0 I component or I0 component. Let's look at I0. Now we are going to look at I0 component. I0, I, this is I, and then this is I, alpha is I, alpha is I, beta is 0, beta is 0, beta is 0, and then beta is 0. Now let us see what simplification we can achieve here. This is I0 component. F bar I0. This F bar I0 is a value in the background FRW space. So I0 component will be 0 because F bar alpha beta is a diagonal tensor, diagonal matrix in the, it's a diagonal matrix in the background space. So I goes from 1 to 3 and this is 0. So this component will be 0. So we can remove this component. Now we are left with this. And here again, this is a diagonal matrix. So only the 0 component will survive in the second term here. Only the 0 component will survive here. Because in the background universe which is homogeneous and isotropic, any tensor with the two indices like 1 1 or alpha beta, 1 1 or 0 2 or 2 0, a tensor with two indices. That tensor will have only 0 0 component, 1 1 component, 2 2 component, and 3 3 component. It will be a diagonal matrix. So non-diagonal components will be 0 in the background universe. So only 0 component survives here. So this becomes this. And here again, if we contract on new, 0 component will vanish and only the j component will survive. 0 will vanish. So I can remove the 0 part and replace this with the new with j. So out of j again we see that only I component survives, and this I have explained in one of my previous videos how we can write this matrix in terms of its trace. So I can write this matrix in terms of its trace like this. You have probably seen this in GR and the course on standard cosmology. So if there is any confusion, refer to one of my previous videos where I have explained this. So this will become, this becomes 1 by 3 delta ij delta I takes time sometimes to type in Mathematica, but I love it. ij. See, formatting takes patience here. Oh my god, I don't like this I. Okay, now this I think we can fix. There you go. Okay, so I write this as yeah, let me not miss any step here. This I replaced contracted on new, 0 0 component vanishes and then only j component was left here. Now f bar ij I'm going to write as 1 by 3 delta ij f bar kk. And again, if there is any confusion, please refer to one of my last videos where I have explained this. Okay, so this f bar ij is 1 by 3 delta ij f bar kk. F bar kk represents the trace of this matrix f bar ij. So this is the trace, and this is 1 by 3 delta ij. Yeah, so f bar ij is 1 by 3 delta ij and trace. Okay, now look at the last term. So delta ij when applied to xi j, then xi j will become xi I. Xi j becomes xi I, and this delta ij is now gone. Okay, so we have this. If you like, you can write it like this, or you may want to factor out xi I 0. Minus the trace. This is the trace. Sorry, trace of ij matrix. The special matrix f bar ij. Not the full trace of f bar alpha beta. Full trace will be f bar 0 0 plus the xx yy and zz component. but here we are taking only this f bar kk represent trace of 3 by 3 spatial matrix, so which is this 1 1 2 2 and 3 3 component. Okay, so split it like this. Yeah, so that's I think as far as we can go with the simplification. Yeah. So delta fi0 transforms according to this relationship from gauge 1 to gauge 2. Now let us look at the 0. This was I0. Now let us do the 0i component. We'll start with this equation again and write the 0i component. 0i component. Zero I component. Okay, so we write 0 here, I here, beta is I, beta is I, beta is I, beta is I, alpha is 0, alpha is 0, alpha is 0, alpha is 0, and alpha is 0. Okay, now this 0i again, f bar alpha beta is a diagonal matrix, so non-diagonal component will vanish. This is non-diagonal component, second term. So let's do that simplification. Okay, this will vanish. Now here f bar, if we contract on mu, let's look at the second term simplification. If we contract on mu, 0i component will vanish, only j component will survive. So our first simplification is to replace mu with j because 0i component vanishes. So, and here only f bar 0 0 component survives. So f bar 0 1 0 2 0 3 will vanish. So here only 0 component will survive. 0. Okay. Now second term, again we can write it in terms of its trace. This f bar ji, I can write as delta ji in this form. What is that? This 1 by 3. So this I can write as 1 by 3. But now instead of saying ij, I have to say ji. Ji. And this then will be kk, which is the trace of f bar ij. 3 by 3 spatial matrix, trace of 3 by 3 spatial components, spatial matrix, sum of the spatial components. So this is like f bar 1 1 plus f bar 2 2 plus f bar 3 3. And now second term we can apply delta ji to xi 0 j, and xi 0 j, when we apply delta ji, this becomes like this. Okay, so we can factor out 0 xi 0 I if you like, only if you like, otherwise there is no need. We can leave the solution here up to this step, but if you like, you can write it like this. Or if you want to compare it to the I0 form, then you can say this is minus here and the inside term is the same as the previous one. Yeah, here you go. So here you had plus xi I with respect to 0 and then this. Then here you have minus I 0 with respect to I, and then inside is the same. Now the last is the ij component. Let's look at that. Ij component starting from here. Let's write the ij component. Alpha is I, alpha is I, alpha is I, alpha is I, alpha is I. Beta is j, beta is j, beta is j, beta is j, and beta is j. Okay. Now f bar ij. Let's see. Let's do simplification one by one. F bar ij is delta ij. We have looked at it here. One by 3 delta ij. This is 1 by 3 delta ij. Oh my god. 1 by 3 delta ij and then f bar kk. Here you go. And actually this partial derivative with respect to 0 is applies to delta ij and f bar kk together, but delta ij is constant, it comes out of the derivative. So derivative is left only on the f bar kk part, and this comes out. So this f bar ij we replace with delta ij f bar kk. Second part simplified. Is it? Yes, it is. Okay. Now coming to this part, f bar mu j. First thing is that when I contract on mu, the first contraction term, the first term that comes out after contraction will be 0, 0, and 0, 0 component will vanish because f bar alpha beta is a diagonal matrix. So 0 j component will vanish, and I am left with now, let's say, m and m. So m goes from 1 to 3. 0 component gone because f bar 0j is 0. Similarly here, and now we'll simplify this further. I will write this in this form. Now here again, sorry, this is something wrong here, or no, ij, this is correct. And here again, 0, 0 component, we have to contract on nu. When we contract on nu, first term is 0, and that f bar I0 is 0. So that is gone, and we are left with the now m here and m here. M goes from 1 to 3. Okay. Now next simplification can be f bar mj is basically 1 by 3 delta 1 by 3 delta mj mj and f bar kk bar kk. Good. So next is this, also we can write it like this: 1 by 3 delta im I m, and this is f bar kk kk. Good job. Okay. Yeah, so delta mj can apply now to can be applied to xi im, and it will replace m with j here. Okay, so delta mj done its job, it's gone. Now delta mim will do its job here, and this will become I j, and 1 by 3 xi I j f bar kk minus 1 by 3 xi I j f bar kk. This is gone. So the last two terms cancel each other. There you go. Was there another way of looking at it, or did we have to go through all these steps? Let me see. Here m, and here it is I. I think these steps were necessary. Okay, so we did all the required steps in order to cancel the last two terms. Now we are left with this. So we have delta Fij is equal to this. So delta Fij transforms according to this relationship. Perfect. Now, if we look at the traceless part of delta Fij, what is the traceless part of delta Fij and what is the trace part? Okay, so the traceless part of delta Fij is, let us first look at the trace part. Trace part of delta f kk. Let us see how the trace part transforms. Can write the trace part of delta Fij as this is equal to delta, my god, does it always do like this? So I can write delta think we can fix it. Okay, it is this, and this will be equal to its transformation is equal to this is m here and M here, M here, and M here, and M here, and M here. Good. Now what is delta mm? Delta mm, it contracts on M. So when it contracts on M, we get delta 11 plus delta 22 plus delta 33. Delta 11 is 1, 22 is 1, 33 is 1. So this is equal to 3. 3 divided by 3 is 1. So this is 3 and 3 by 3 is 1. Okay, so this is the transformation of the trace part. Okay, now the traceless part. Traceless part is that I subtract from delta Fij. Now the traceless part of delta Fij. So this is yeah, it's not tilde here. Now let us see what is the traceless part. For the traceless part, I can write I can subtract the trace part from the matrix. So from this, if I subtract the trace part, which is, so if I'm able to subtract from this, sorry, I need to subtract to write it like this. Let me copy this. So this minus this, and actually it is this, and this is tilde. Yes. So this is the traceless part of I start, let me not miss any step. So this is where I started from. I started with this equation, which I have derived here. So when you start with this equation, and for this matrix, this is the trace part, and now I write the traceless part. Traceless part is given by this. I'm subtracting 1 by 3 delta ij from f tilde kk from both sides. So I will write this here also with minus sign. Okay, and this is the traceless part. So this is the traceless part of delta phi j. I subtract 1 by 3 delta ij, and this has to be delta fkk and this. Okay, so I get this expression, and I can replace this delta fkk tilde with this one. So I have traceless part of delta phi j, which is delta phi j minus trace part. Trace part is this. Now on the right hand side, I can, because I want to express the right hand side in terms of everything in gauge 1. Left hand side is all in gauge 2, and I want to see that how it transforms in gauge 1. So gauge 2 is this, and I want to look at its expression in gauge 1. So I need to put its value in gauge 1. In gauge 1, this is equal to this. It won't let me copy the right hand side, but no problem. I can copy the whole, and then I can delete the unwanted stuff. This I can call it KK if you like. Okay, now here you can see that this term, second term and fourth term, they cancel each other. So this greatly simplifies to, this is gone, 2 is gone. Now this is what we are left with. And what is this? This is a tensor minus its traceless part. No, sorry, tensor minus its trace part. So it is delta Fij minus the trace of delta Fij. So this is the traceless part of delta Fij. Traceless part of delta Fij. Oh my God. Okay, so this is the traceless part of delta Fij, and traceless part of delta Fij in gauge 1 is equal to the traceless part of delta Fij in gauge 2. Hence, the traceless part of delta Fij is gauge invariant. Traceless part of delta Fij is gauge invariant. Means its value its value is same in all the gauges. Okay. That's it for today. Thanks for watching. Keep having fun with physics and cosmology. May these equations stay with you for the rest of your life. Keep solving them, keep finding new stuff, and keep contributing with your research skills and teaching skills and learning skills. Have fun. Thank you. See you next time. Bye bye.